Not sure. I don't think so.
I have already uploaded that on YouTube, so you can refer to it.
Okay.
Okay.
So,
Yeah.
mhm.
So let us start with the next part, that is combustion reaction. So we are done with uh, synthesis, we are done with decomposition, we are done with single displacement, we are done with double displacement, right? And we understood in double displacement how to use the solubility to predict the reactions,
Yeah.
right? So
Yeah.
after that, the next reaction that I have wanted to cover is the combustion reaction. So what I'll do is I'll try to explain you the method that I follow to balance the organic or combustion reactions. Okay, so can you see this example? We have C6H14, right?
Yeah.
So whenever we talk about combustion reaction, mostly we will talk about complete combustion. Okay,
Okay.
so when we talk about complete combustion, there are two products. One is carbon dioxide and other is water. Okay,
Yeah.
so if you see organic compound means that contains carbon and hydrogen. If that undergoes combustion, that is reaction with oxygen, we will get carbon dioxide and water as the byproduct. Correct?
Okay. Yeah.
So now in this, if you notice, oxygen, right, on the reactant side is at one place. However, in the on the product side, it is at two places,
Yeah.
right? So
Mm-hmm.
whenever you see that a reactant is at multiple places on the products or on the product side, you
Mm-hmm.
will not balance it at the first.
Okay.
So always start with a reactant which is at the least places on the product side.
Mm-hmm. Okay.
So with that logic, we have carbon and hydrogen. Carbon is at one place, hydrogen is also at one place.
Okay.
Correct?
Yeah.
So what I'll do is I'll balance the carbon. So we have six carbons over here. So I'll multiply this by six.
Mm-hmm.
Okay. And I have hydrogen, which is 14. So I'll multiply this by 7.
Okay.
Correct.
Yeah.
Now, if I look into the oxygen, so there are 6 into 2, 12 with carbon dioxide and 7 with water.
Yeah.
So total I have 19 oxygens.
Okay.
Correct.
Yeah.
Okay. And so that is an odd number. Correct.
Okay.
And O2
Yes.
on the reactant side is a even number.
Mm-hmm.
Right. So what I'll do, instead of writing that as 19, I'll write it as 19 by 2. Does that make sense?
Mhm. You can use like a fraction number.
In order to balance, I'm using it,
Okay.
but I'll not retain it as it is.
Okay.
So now, if you see in the next, I'll multiply this by 2. So I
Okay.
have 19 O2, I have 2 C6H14, 19 O2, 12 CO2, 14 H2O. So that
Okay.
way I have got rid of the fraction.
Okay.
Okay.
Yeah.
So if this number is even, you can just divide that by 2 and you can write down. But if
Okay.
that is an odd number, then write a fraction that is
Okay.
divided by 2.
Yeah.
Okay. Copy that.
Okay. I copied it now.
Okay. Now check the second equation.
Okay.
Sorry, third equation. C7H16 plus O2.
See. So.
Can you see that on the screen?
Yeah.
So if you see, that's a combustion reaction. Only difference is here I have even number carbon, here I have odd number carbon.
Okay.
Can you try and use the method and solve it?
Okay. So I'm gonna put three, nine, 6. I'm done.
Okay, done.
Yeah, I'm just
Tell me
gonna.
the answer.
I got C7, H16,
Yeah.
it's 10 oxygen, like
Yes.
10 O2, becomes 6 CO2 plus 8 H2O.
How many CO2? 6 CO2?
6 and then 8 H2O.
Are you sure? 6 says CO2,
Oh, sorry. 7 CO2.
7 CO2, and
Then 8 oxygen. But I think that'll be also wrong because then, wait,
8
maybe.
H2O was correct.
Okay.
Okay, but yeah, this number will change then.
Yeah.
7 CO2 plus 8 H2O. So now I have 14 plus
Mhm.
8, that is 22. Okay, even
Okay.
number. So I'll get
And
11.
11 O2.
Yeah.
Okay.
So try two more. C5H, maybe 10, and C6H, sorry, not C6 is already done. C4H10. Another one we'll do C4H10. So one odd and one even. Can you try?
Okay. Like, is that what's the reactant for that? Sorry,
So
like the product.
combustion.
Yeah.
So when it is combustion, it is oxygen, other reactant.
No, I'm a bit confused. Like, how do I balance that? It's just one.
So yes, C5H10, right?
Yeah.
So now it is undergoing combustion reaction.
Yeah.
So when it is a combustion reaction, that means it is reacting with oxygen.
Mm-hmm. Oh, okay.
And the product will be carbon dioxide and water.
Okay.
So you don't, when you get the question in the exam or on your quiz, they'll just
Mhm.
say combustion of this compound. And you're supposed to write it down and balance it.
Oh, okay.
Okay.
C5H10 plus 10O2. That becomes 5 CO2 plus 5 H2O.
Okay. So how much is that?
5 CO2 plus 5 H2O.
Yeah, that's correct. But what about the oxygen?
Oh, there's 10O2.
Uh, Let me confirm that. Okay. So you said 5 CO2, that's fine, and
Mhm.
5 H2O, correct?
Yeah.
Okay, now we have 10 plus 5, 15 oxygens, odd number,
Oh, yeah.
right?
Okay.
So when we
Yeah.
have a odd number, 15 by 2,
Okay.
right?
Yeah.
So probably I might have told you this odd and this odd even number and this odd number, right? So we'll focus only on the oxygens, whether that is an odd or even number. Okay.
Okay. entire equation by 2, so it's like 2C5H10 plus
Yes. So you
plus
got
15O2
that's correct.
becomes 10CO2 plus 10H2O.
Yeah, that's
That's
correct.
mhm.
Okay, and the other one, C4H10, try that. I'm on mute, but I'm there.
Okay, for my final answer, I got 2C4H10
That's correct.
plus 13O2
That we'll check.
plus 8CO2 plus 10H2O.
So 16, yeah, that's correct.
Mhm.
Good job.
Thank you.
So we are done with combustion reaction. Anything else on that? Yes, now one more part,
Okay.
which is also critical, which you should know, is about incomplete combustion.
Okay.
Okay, so incomplete combustion is because there is lack of oxygen.
Okay.
Okay, so C6H4, when same thing, like when it is combined with oxygen, we can get carbon dioxide, we can get carbon monoxide, and we can get water.
Mhm.
Okay, also there are times where we can get carbon, that is black soot.
Okay.
Okay, so that is also possible. Like if you have seen uncontrolled fire anytime,
Mhm.
so in that there is production of carbon monoxide, there is production of black soot, smoke, right? So that is clear
Yeah.
indication that there is lack of oxygen.
Okay.
Okay, we will not try to balance it
Oh,
because we don't know how much of oxygen is supplied,
okay.
right? So different if we'll always have different products and
Okay.
different amount of products.
Okay.
Okay, so we will try not to balance it. Okay, then as I told you, carbon dioxide will be there, carbon monoxide will be there, water will be there, and black soot will be there. Out of that, this is extremely dangerous,
Mhm.
right? It's a poison,
Yeah.
right? So we know that, and that's the reason each and every house has a carbon monoxide detector, each and every floor, I should say now,
Yeah.
right? So now, why is it dangerous? Let us understand that, although not related to chemistry, like but it's good to have that understanding. So you
Mhm.
have hemoglobin in our body, on
Yeah.
in our blood, right?
Yeah.
So that carries the oxygen to the different tissues.
Okay.
So it forms a complex with oxygen, which
Mhm.
is reversible. That means it is easy to break.
Mhm.
So in the lungs, hemoglobin combines with oxygen to form this reversible complex. It carries it to the tissues where oxygen is required, and it releases the oxygen to the tissue.
Okay.
Okay. And then again, this hemoglobin is circulated back to the lungs where it is gets oxygenated, right? And the process continues. So it's a cycle.
Okay.
Okay. Now, what happens when carbon monoxide is present? So this hemoglobin combines with carbon monoxide. Now, this complex which is formed is irreversible,
Okay.
right? Because it is irreversible, the tissue is not able to get oxygen.
Yeah.
So that results into a condition called as hypoxia for
Okay.
the tissue.
Yeah.
So hypo means less oxygen.
Okay.
Okay. And that if the amount of hypoxia is lot,
Mhm.
it can be fatal to the person.
Okay.
It depends upon which tissue is getting affected, right?
Mhm.
Any
Yeah.
doubt?
No.
So that's the reason, like, uh, we should be aware of what are the dangers of carbon monoxide. Okay,
Okay. Yeah.
right. Also, one more point that I want to address is that carbon dioxide is heavy than air.
Okay.
So what happens is if there is a lot of carbon dioxide, that is also not safe.
Yeah.
What happens if carbon dioxide is present? The oxygen in the air will be displaced.
Okay.
So people will can suffer hypoxia even when there is a lot of carbon dioxide. So it doesn't mean that carbon dioxide is safe. Okay,
Okay. Yeah.
so that's the reason when you have dry ice and the other stuff, you have to be
Mhm.
more careful.
Yeah.
Okay,
Okay.
that's so that's conclude our all the reactions, right?
Mhm.
We have covered all this part earlier. Mm, incomplete combustion. I think I've covered all this part for you. So that is completing the unit chapter 5, right?
Okay.
So we are done with chapter for like till chapter number 5. Now let us start with a new chapter uh that takes you into the world of moles and mole concept.
Okay.
Okay, so I'm sharing the screen with you. So any difficulties so far, whatever we did,
No, not so far.
no,
Yeah.
right? Everything is clear.
Yeah.
Okay, good. So now there will be lot of calculations that would be involved when we do the mole concept. Okay,
Okay.
so when we talk about mole concept, okay, let us understand first what is the meaning of the term mole.
Okay.
So can you see the screen,
Yeah. It's
right? So do you know the meaning of this term dozen?
like 12 means.
Yes.
Yeah.
So dozen is a number, right?
Mm.
Dozen is a unit which represents number 12.
Yeah.
Pair is a unit that represents number 2.
Okay.
So if you go to Walmart and buy, let us say, a dozen of apple, so you know that you have purchased 12 apples.
Mm-hmm.
If you go to the, let us say, someone over there and you are not able to find 12, and if you ask someone at the store that, okay, can you help me with 12 or a dozen of apple, that person understand that, okay, that means you need 12 apples,
Mm-hmm. Yeah.
right? When we talk about pair, everybody understand that you're talking about two,
Okay.
correct?
Yeah.
Similarly, whenever we talk about mole, we are talking about a number. So it's a unit representing a number.
Mm-hmm. Okay.
That number is 6.022 into 10 raised to 23,
Okay.
also called as Avogadro's number. Okay.
Okay.
But when you go to Walmart, okay, and if you ask for 1 mole of apple, what do you think? Is it possible to get 1 mole of apple from Walmart?
No,
Why?
because it's like a decimal number. It's really big. It's like an exponentially large.
Yes, so because it's a large number, it's not possible,
Hmm.
right?
Yeah.
So there is a example given in your textbook where it says that if you take uh, 1 mole of peas, green peas,
Hmm.
okay, it can cover the entire circumference of the earth 3 times.
Okay.
So that number is so huge, right?
Hmm. Yeah.
So it is not used in our day-to-day life,
Okay. Yeah.
right? Can you copy this down?
I did.
Good. Okay. And did you mention Na is Avogadro's number?
Pardon?
Na is called as Avogadro's number.
No, I didn't. Sorry.
Can you mention
N
that?
NA is a
Avogadro's number.
okay. Yeah.
Okay.
Yeah.
So that's done. Now, where is it used? Because it's such a large number,
Hmm.
it is used for microscopic entities
Okay.
like electrons, protons, neutrons, atoms, ions, molecules.
Okay.
Okay. So if in a lab, if you go and you ask for 1 mole of sugar,
Hmm.
we can get 1 mole of sugar.
Okay.
Okay.
Yeah.
And it is easily quantifiable.
Okay.
Does that make sense?
Yes.
Sugar in the sense, what is sugar?
It's like
It's sucrose.
sucrose. Okay.
Yeah. In a in a lab, if you go and ask for 1 mole of sodium chloride, it's easy
Mhm.
to get.
Okay.
Okay.
Yeah.
Have you copied this?
Yes. I'm just finishing up the last thing. Scope. No, I'm done.
Okay, good. Easy so far.
Yeah. So far it's
Now to understand the use of this concept, okay, what we need to do is we need to understand how to calculate molar mass.
okay.
Okay. So I'm first talking about how to calculate molar mass, and then we'll try to understand how does it involve in the understanding what is mole, how to relate it with molar mass and so. Okay. So what is molar mass is you should know the formula of the compound, molecular formula. Okay.
Mm-hmm.
To calculate molar mass, you should know the molecular formula.
Mm-hmm.
Once you know the molecular formula, what we do is we write down each and every atom multiplied by the number of atoms that are present in that molecule. So each and every element multiplied by the number of atoms of that element in the molecule.
Okay.
Can you see ammonium phosphate? So there are 3 nitrogens. Clear?
Yeah.
There are 12 hydrogens. Is that clear?
Yes.
There is 1 phosphorus. Is that clear?
Yeah.
And there are 4 oxygens. Is that clear?
Mm-hmm.
Then what I do is from the periodic table, I write down the atomic mass of each and every element.
Okay.
Nitrogen is 14, hydrogen is 1. So I've rounded it to the whole number. Okay.
Okay.
Phosphorus 31, oxygen is 16.
Okay.
We do the multiplication, right? And then we add everything.
Okay.
Okay. What we get is the molar mass of ammonium phosphate. Can you calculate that and check? And I'll be back in a minute.
Okay. No problem.
Yeah, I'm back.
Okay, I got 149.
That's good. Now let me make you understand what is the meaning of that. So
Okay.
when you weigh 149 grams of ammonium phosphate,
Okay.
you actually are weighing 1 mole of compound.
Okay.
That means you are actually having 6.022 into 10 raised to 23 molecules.
Okay.
Okay, and that is what was proven by Avogadro.
Okay.
And hence this number is called as Avogadro's number.
Okay. Yeah.
Okay, we will come across like how he was able to prove that number. We'll come across that in future when we talk about different concepts.
Okay.
Okay, for today's lecture, let us believe that 1 mole is actually 6.022 into 10 raised to 23.
Okay.
Okay, any doubt?
No.
Okay, now what I want you to do is calculate the molar mass or molar mass of CO2, H2O, Al2O3, and
203.
Al2O3 and ammonium sulfate. Okay, calculate the numbers and tell me. And do one thing, send me the image on WhatsApp. Let me see whether you have done the calculations correct. Okay. Yes, Liam.
Mhm.
Yeah, I got your mm, message. I- Yeah, can you see the image that I'm sharing with you
No, I still see the Word document.
now?
Yes, now I can see it.
Yeah. So we have for H2O, that's correct. 18, carbon dioxide 44. Yes, that's correct. Aluminum is 27 to 16, 3.8. Okay, that's correct. Ammonium sulfate, fine. I believe you know the method now.
Mhm.
So, but what is important? You should know that when you convert this to grams, by default, you are having 1 mole.
Okay.
Correct? So I'll stop sharing this and I'll go back to the Word document. Right? So now let us understand how to convert mass to amount.
Okay.
Okay. So to convert mass to amount, we will use the formula N is equal to M over capital M.
Okay.
Okay. So where the small m represents given mass in grams, capital M represents molar mass in gram per mole
Mhm.
or lowercase, uppercase, whatever you want to call.
Yeah.
Okay.
Okay.
Have you copied the formula?
Yes.
Okay. Another concept is percentage composition. We will learn this later, but for now, just write down the formula. So if you want to determine the percentage of carbon in carbon dioxide, you will write the mass of carbon, atomic mass of carbon in carbon dioxide divided by the molar mass of carbon dioxide multiplied by 100.
Okay. Um, how do we note the molar mass of carbon dioxide?
That you need to calculate. Just now you calculated 44.
Oh, okay. Yeah.
Yeah. And
Yeah.
you know the mass of carbon. I have
Yeah.
written molar mass there, but actually that is the atomic mass.
Mhm.
Okay.
Okay.
And whenever you are calculating the last element, you just have to subtract from the one that you have found. So for example, here I got 27% carbon
Okay.
and there are only two elements, right?
Yeah.
So the third element, sorry, the second element is just 100 minus 27.
Okay.
Okay. So same thing over here for H2SO4, right?
Yeah.
Can you calculate?
Okay. Mm. Should I send you the image when I'm done or?
No, it's fine. Just tell me the numbers.
Okay.
Yeah.
So I calculate the percentage for each item or just sulfur?
For each item, hydrogen, sulfur,
Oh, okay. Yeah.
and oxygen. So that I know that you know how to use the formula. So this unit is entirely entirely all about calculations.
Okay. So for H2SO4, for hydrogen, I got 1 times 2 equals 2. Sulfur, 32 times 1, which is 32. And oxygen, I got 4 times 16, which is 64. And then altogether, it has 98 grams.
Yes.
And then for hydrogen, I did 2 divided by 98 times 100, which
Yeah.
is 2.
Correct.
For sulfur, I did 32 divided by 98 times 100, which is 33 rounded. And then
30 or 32?
32.
33. Okay, that's fine.
And then for oxygen, I got 64 divided by 98 with times 100, which is 65.
Okay.
And yeah, that's all.
So that's done. Okay, now what I want you to do is we will do now. Okay, just check the question. The question says that we need to calculate the amount from each of the samples. Okay, the
Okay.
formula that we will use will be N, like I'm making a triangle over here,
Mhm.
M over capital M. Okay,
Okay.
so if you want to determine N, the formula is mass in grams divided by molar mass in grams.
Mhm.
Okay, it's actually gram per mole.
Okay.
Okay, and if you want to determine mass, the formula is N into M. So if you want to determine this, just multiply. If you want to determine this, just divide.
Okay.
Okay, can you try the first one? And if you know the compound,
Yeah.
you know the molar mass.
Okay.
Okay,
Okay.
so this information is known to you if you know what compound it is, or what atom it is, or what
Okay.
element it is. Okay,
Mhm.
can you
Okay.
try A, C, and E?
A, C, and E. Okay.
Yeah. If you are struggling, don't worry, I'll help you. But I want you to give it a try. Solve the first one, share the image with me. Let me confirm whether you are doing it right or not.
Okay. Okay, I wrote my solution on like the last like part.
Just share the image with me so that we discuss. If the approach is correct, then you can proceed to, okay, I received it. Give me 1 minute. So 500 gram of NaCl, that's correct. You have calculated the molar mass, that's
Oh,
correct.
uh,
Whenever you write molar mass, I want you to write gram per mole.
yeah. I
Okay.
accidentally made a mistake. I put 5 grams. It was supposed to be 58 grams.
Yeah.
Yeah.
So this should be 58 gram per mole.
Hmm.
So the gram and gram gets cancelled, 8.5 moles. And I want you to write down the formula when you do it.
Okay.
Okay, like when you do it in the school, the formula would be expected.
Okay.
Okay, fine. I think you're good. You know that. Okay, you can do now the next, that is C and E.
Okay.
If I believe you know the conversion of kilogram to gram, right?
Yeah.
Okay, and milligram to gram.
Milligram. Yeah, I think so.
Okay, try it and let me know. Once you are done, just share the image with me.
I'm currently doing E right now. And then
So I saw the image C, and that's correct
okay.
for the C problem, and that's correct. You can do E, and then we can move to the next part. Yes, Leanne, I saw the problems. That's correct. All whatever you have solved is correct.
Okay.
Okay.
Yeah.
One point I want to highlight is that if you see
Yeah.
the question over here is having four significant figures,
Yeah.
right? So
Mm-hmm.
your answer should also have four significant figures. Here
Oh,
you have three significant figures. So the answer should also have three significant figures.
okay.
Check over here. One, two, three. Here also you have three significant figures.
Okay.
Okay. Here you have three significant figures. Here you have three significant figures.
Okay.
Okay. So just that is one improvement that you need to do. And again, the units are missing whenever you are writing the values.
Okay.
Okay. So can you do the second A, C, and E? Now you need to do the mass from the amounts. Will you be able to do it?
Yeah. Okay.
Okay. Solve A, C, and E and share the image for the three.
Sir, what does MMO mean for C?
Sorry. I was trying to unmute and it took time.
Yes.
Millimole.
Oh, okay. So it's like divide by 1,000.
That's correct.
Okay. Okay, I'm going to send the photo now.
Okay. Have you sent or you're sending?
I'm sending. I'll just like underline the answer.
Sorry.
Uh, no, I said I'll like underline the answer because like it's kind of hard to tell.
Yeah, all good. Yeah, and you there? Leanne, you there?
Yes, I'm here. Can you hear me?
Yeah, I can hear you now.
Oh, sorry. I thought like my mic was muted, but
Okay.
okay.
So we have Avogadro's now. The next is Avogadro's number, that is Na. So if you want to convert anything to the number of entities, like now we were converting moles to mass. right? And mass to moles.
Okay.
But if you want to convert moles to Avogadro, like number of entities, number of atoms, number of ions, that is also possible
Okay.
using the Avogadro's number, that is 6.022 into 10 raised to 23. Can you
Mhm.
write down this formula?
Yeah.
And we can use a similar triangle as we had earlier.
Okay.
So N would be capital N over Na. So if
Okay.
you need number of moles, it is number of entities over Avogadro's number. If you need number of entities, then it is number of moles multiplied by Avogadro's number.
Okay.
This is easy, right?
Yeah. Sorry, I'm just copying down like the n equals number of entities. Yeah.
Go ahead, no problem.
Okay, I got it done.
Now, there are some questions. If you could,
Mhm.
can you try to solve these now?
Mhm.
So, okay, now pay attention over here.
Okay.
You have been given the mass,
Okay.
right? You know the entity, what it is, sorry, like the element. So
Okay.
from these two information, you can find out the moles,
Okay.
correct?
Yeah.
After you get the moles, then comes the determination of capital N. Okay.
Okay.
So if mass is given to you,
Yeah.
you will determine N.
Okay.
And from that N, you will determine the number of entities.
Okay.
Correct?
Yeah. Mm.
Will you
Yeah.
be able to do it?
Yeah. Okay. Okay. So wait, is it similar to what I was doing before? Because like now I got a bit like lost. Yeah, like so from the
So,
mass I determined the number of entities.
so
And
you
then
have the mass given over here, right?
yeah.
Now, because you have the mass, you will divide that by the molar mass,
Okay. Yeah.
right? You will get the moles.
Mm-hmm.
Once you get the moles, you will multiply that by the Avogadro's number. You will get the entities,
Okay.
right?
Mm-hmm. And that's it.
Yes.
Okay. I
So
can.
the conversion is mass will be converted to moles and
Mhm.
moles will be converted to number of entities.
Okay.
And number of entities can be converted to moles and moles can be converted to mass. So you have,
Okay.
if you want to convert mass to moles, you divide by the molar mass.
Okay.
If you want to convert number of moles to entities, then you multiply it by the Avogadro's number. But if you want to convert number of entities to moles, you divide by Avogadro's number.
Okay.
And if you want to convert number of moles to mass, you multiply by the molar mass. So if you
Okay.
want, you can copy this so that it is easy for you.
Mhm. Should I move
Leanne,
to the
can
rest of?
you see the screen
No, I can't.
now?
Yes, I can. Yeah.
Okay, the number of moles are correct, but
Mm-hmm.
Avogadro's number is Na, not
Mm-hmm.
like what you have represent over here. That is Na. Na is incorrect. It's N.
Oh, okay.
Na is 6.022 into 10 raised to 23.
Okay.
Okay, so the answer that you get is number of entities,
Mm-hmm.
and you have written Na, so that is incorrect. So
Okay.
make that correction. Okay,
Okay, I corrected it.
yeah. I'll go back to the document again, and then you can do Cn. Uh, Maybe you can do the third and fourth.
Sir, I'm going to be right back for just 1 minute. I'm just gonna get something really quick.
Yes. Leanne, what happened?
Hello? I'm so sorry. My mic was muted while I was speaking. I
Oh,
have the third question done. However, I'm working on the fourth one. Should I send them both together
yeah,
or
both
should...
of them together you can send.
Okay. Okay. I'm sending both of those now.
Yeah, I got the image. So again, the same correction. Like if you see
Mhm.
uh, 7.3, right?
Yeah.
The answer that you wrote is 1.56.
Yes.
So you need to,
Oh, round it.
mm,
So it's 1.6.
that's correct. So there should be only two significant figures.
Okay.
Okay, that's fine. Same thing with the next one.
Okay.
Okay, and that should be all then.
Okay.
Let me see if there's anything pending from Earth. I believe, yeah, that should be all for today. We did combustion. Okay, that's this. Okay, I think we are good, and in the next class can start with. Okay, would you take down these questions and try to solve them? Okay, take the
Okay.
screenshot and do these as homework.
Okay. Sounds good.
And we can connect next week.
Okay. Sounds good.
Okay,
Okay.
then.
Bye, sir.
Bye. Yeah,
Have a good day.
you too.